Hello everyone and welcome to our third part of our right triangle trigonometry test. So in this video, we're going to answer all of the given trigonometric functions with its given special angle. If we have a given trigonometric function and a given special angle as an input, in there we can find an exact value for it. All right? Because if the angle is special, there is a moment where the answer could be just a whole number, a fraction, or an irrational number, right? Like, for example, like square root of 3 all over 2. But you see, even if it has a square root or something, we can represent it as an exact value of it. Not like those other angles that if you're going to substitute it in a function, you will have like multiple decimal values. So that's why we approximate it into either two decimal places or three decimal places. Anyway, let's begin. All right. So how to find the exact value of sine of 135 degrees? So here I taught you guys two techniques. One is just the use of your hand technique, or with the use of your hand. All right, wait, let me just enlarge my camera. All right, there we go. With the use of your hand. All right, wait, this one with the use of your hand. Or we can just use the second technique, which I highly recommend, which is the application of reference angle and then the use of hand technique. All right. So let's have a recall. What's the hand technique am I referring to? All right. So just imagine that this is your hand, all right? Please forgive my drawing, okay? This is your hand. So this is like the thumb, the forefinger, the middle finger, the ring finger, and the pinky finger. All right? And then oh wait, yeah. Anyway, that's the palm. Okay, this is the palm. So now imagine that this is these fingers represent special angles. Here we will start from 0 degrees. And here on the ring finger, 30 degrees. The middle finger will have 45 degrees. The forefinger we have 60 degrees. And the thumb will have 90 degrees. All right? Then the thing is, what you're going to do is that these fingers will tell you a number, but it depends on a given trigonometric function. So for example, if you are looking for sine, then the numbers will give you is 1, 2, 3, 4. Oh, wait, no, no, no. That sounds wrong. Wait, wait. Not 4, but rather, wait, wait. Forgive me, guys. Forgive me. It's supposed to start at 0. So 0, 1, 2, 3, and 4. If you have a given of sine. All right. So basically from your pinky finger, 0, 1, 2, 3, and until to the thumb, 4. If you're looking for a sine. All right. Now for cosine, okay, wait, let me just change the color here for you guys not to be confused. That's for the cosine. Now for the sine, let me just use green color. All right. Oh, wait. Wait, I'm confused. This is for sine, right? Forgive me. All right, there we go. So this is for sine. Now for cosine, let me write it here. For cosine, so it's just similar as for the sine, like 0, 1, 2, 3, 4. But instead, you'll count from 0 to 4, but starting at the thumb. So this is 0, 1, 2, 3, and 4. Okay? So I hope you guys follow. And then, of course, in the thumb, you will have a denominator of 2. Okay, on the thumb, you will have a denominator of 2. Let me get that. Okay, there we go. Okay, so let me give you some warm up. For example, if I told you to find sine 90 degrees, sine 90 degrees, for example. So if we are looking for sine of 90 degrees, so what are we going to do? So you're going to start counting from your pinky finger. All right? 0, wait. It's my camera. Wait, hold on. Let me enlarge my camera. Right? So we're looking for sine 90 degrees, and you have your hand right here. You start at your pinky here. All right? You start at your pinky here. So count here: 0, 1, 2, 3, 4. Right? So this thumb is 90 degrees, right? So you stop right here. So according here, this is 4, right? 4. Now, after that, you will square root it. Okay, so what's a square root of 4? So it's 2, right? The square root of 4 is 2. Now, after you get the square root, you divide it by 2, which is on the palm. So you will have 2 all over 2, and the answer is 1. All right? I hope you guys get the technique. Otherwise, you should just watch my previous videos. All right? Or you can just search it in the internet about this. Okay? Or if you want to do it manually without a technique, then just memorize the unit circle. Okay? So now let's proceed here. We can't actually waste time because we have to solve this. So we have sine of 135 degrees. So first and foremost, if I'm going to solve this, I'm going to find its reference angle. All right? So first and foremost, I must know where is 135 degrees. So in a uh, graph, okay, we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and here we have 360 degrees. Mhm. So, wait, hold on. Let me just uh, decrease the size of my camera. Right, there we go. So here, yeah, we have this one. So this is basically the standard graph of the given angles. All right. If we assume that rotating counterclockwise will give us a positive angle. So 135 degrees is located between 90 and 180. So we go from here, then we go here. All right. So let's assume that from this point at the start up to here will give us 135 degrees. Now let's find the reference angle. So reference angle is basically the angle here. All right. The acute angle in a given angle. So which is this one? This is our reference angle. All right. So to get the reference angle, it depends on the quadrant. So it is in second quadrant, right? So for us to get the reference angle, let me just put R here. All right, there we go. For us to get the reference angle in the second quadrant, all we need to do is we just subtract 180 degrees with the given angle we're looking for. I mean, with the given angle we have. So we have a given angle of 135 degrees. Okay, we have this one, 135 degrees. So get the value here, you'll get 45 degrees. This is your reference angle, 45 degrees. All right. Now, after you get the reference angle, now the first thing, now the thing that you're going to look for is it positive sign or negative sign? So how would you know if it's positive or negative sign? It depends on your quadrant as well. All right. And that quadrant will tell you if your sign is positive or negative. Remember that in a quadrant, okay, in a quadrant, you have a given ordered pair, right? Your ordered pair represents as x, y, okay? Your x is just cosine theta. Your y is sine theta, okay? So here, to give you a summary, in the first quadrant, let me just move this one. Let me just move this one. To give you a summary, in an ordered pair, if it's in the first quadrant, both values x and y are positive. On a second quadrant, the x value is negative, but the y value is positive. On a third quadrant, both values are negative, and on the fourth quadrant, the x value is only positive. So that means the y value here is negative. Okay, so now 45 degrees. and then it is sine, right? Sine. So again, sine is the y. So meaning the y value here on the second quadrant is positive. Therefore, we can say that sine of 135 degrees is just the same as positive sine of 45 degrees. Okay? I hope you understand how I get this. All right? And now that we get the reference angle, now what is the value of sine of 45 degrees, which is equivalent to sine of 135 degrees? All right? So what is sine of 45 degrees? So sine of 45 degrees is, let's start from your finger here, right? Wait, hold on. Let me enlarge my camera. There we go. So we're going to start with my hand here. So if it's sine, start from your pinky finger, right? 0, 1, 2. So this middle finger is your 45 degrees. So you have 2. Now get the square root of 2. So it's square root of 2. And divided by 2, you have square root of 2 all over 2. Hence, sine of 135 degrees is square root of 2 all over 2. And that's how we get the answer for the first problem. Okay? But before we begin writing this answer here, let me just what do you call this one? Fix the drawing here so that you guys won't be having a hard time because it's actually a bit mess. All right? So I'm just gonna draw it here. Oh wait, no, no, no. So I'm just gonna what do you call this one? Put the visuals here, right? For a moment. Right? Let me just put it down here. All right? Then same thing goes on for this graph here. Right? We're going to put it here. Right? There we go. Right? So that's it. So now square root of 2 all over 2 is the answer in this case. All right? Square root of 2 all over 2. Okay. Now next, how about tangent of 240 degrees? So again, in my technique, if I'm going to solve it, I'm going to find its reference angle. Okay? So where is tangent of 200? Ah, wait. The angle, I mean. Where is 240 degrees? Okay. So 240 degrees is actually between 180 and 270. So 240 degrees is starting from here, going through this, right? This one. All right, this is 240 degrees. Now let's get the reference angle. All right, so the reference angle is just basically an acute angle from the x-axis. So from here to here, we're going to get the reference angle. Now, how to get the reference angle if the angle is located at the third quadrant? So all you need to do is simple. All right. So here we have a reference angle on a third quadrant. If it's in the third quadrant, all you need to do is you're just going to subtract that given angle with 180 degrees. Okay, subtract that given angle with 180 degrees. So we have 240 degrees, right? So subtract it with 180. So let's get my calculator. So let's take a look. 240 minus 180, you'll get exactly 60 degrees. So this is 60 degrees. Okay? Now, here's the thing. We are looking for tangent of 240 degrees, right? Now, here's the thing. Is it positive or negative tangent? How do we know if it's negative or positive? All right? So, remember that in a tangent, okay, in a tangent here, we can simply rewrite this into this sine of 240 degrees all over cosine of 240 degrees. We can simply rewrite it this way. This is based from the quotient identity. So tangent is just the same as sine all over cosine. All right. Now we get what is sine 240 and what is cosine 240. All right. Let's start first with sine. So okay, we have 240 here. And then the reference angle for 240 is 60 degrees, right? Now, is sine positive or negative? According here, remember that your y is your sine, your x is your cosine. Now, if you're going to take a look, both of them are negative. Both of them are negative. So therefore, we can simply rewrite this as negative sine of 60 degrees all over negative cosine of 60 degrees. And since both of them are negative, so we can simply cancel out these negative signs and we will have sine of 60 degrees all over cosine of 60 degrees. And there we go. All right. So yes, tangent of 240 degrees is just the same as sine 60 degrees all over cosine of 60 degrees or tangent of 60 degrees. All right. So what we're going to do is we're going to get the value of each of those functions. Let's start first with sine 60. So, okay, we will use the hand, all right? So sine 60 degrees. So always start with your pinky. So 0, 1, 2, 3. 60 degrees is in your forefinger, all right? So this is 3. So now what we're going to do is what? Square root it. So you will have square root of 3. And divided by 2, you will have square root of 3 all over 2. Therefore, you have square root of 3 all over 2. Now for cosine 60 degrees. Now for cosine 60 degrees, instead of counting 0 to 4 from pinky to thumb, you'll start from the thumb to pinky. Okay? Until you reach 60 degrees. Remember that the position of the angles are not changed. So if 0 is here on your pinky, then that is where 0 degrees is. Okay? So let's start. So we have 0, 1. Oh, wait. 0, 1. Here, 1. Your forefinger. We will stop right here because this is where 60 degrees is. All right? So because we have 1 for your cosine when you have 60 degrees, so you will have 1. Now square root it, it's still 1. And divided by 2, 1 half. So you will have 1 all over 2. Now we will simplify this fraction. So all we need to do is we copy the numerator, square root of 3 all over 2, times we get the reciprocal of the denominator, or basically you switch the positions of the given numerator and denominator. Exchange their position. So you will have 2 all over 1. Now you see we have 2 on the bottom and on the top. We can just simply cancel them. So you will have square root of 3 all over 1, or just simple as square root of 3. So the answer is square root of 3. All right? So this is square root of 3. Okay? There we go. So we're done with the second problem. Now let's go to second of 360 degrees. Okay, so let's erase this one. All right, so let's go for second of 360 degrees. Now, if you guys confuse like what is secant, what is cotangent, or other trigonometric functions that that are not sine, cosine, or tangent, you can convert it into sine, cosine, or tangent if you know its identity. So we have secant, right? Secant of 360 degrees. According to reciprocal identity, this is just the same as 1 all over cosine of 360 degrees. And that's it. We already converted into cosine. And yeah, we're good to go. All right. Now, what is cosine of 360 degrees? Okay. So here, if you're going to take a look at the graph, if you're going to graph 360 degrees, hold on, let me just erase this. It's just basically one whole revolution. So from here, going there. That's a total of 360 degrees. That's one whole revolution. And now that this is one whole of revolution, so what does it mean? Meaning that 360 degrees is just the same as 0 degrees. You get me? Basically, cosine 0 degrees is just the same as cosine of 360 degrees. So, what is cosine of 0 degrees? Oh, let's go back to your hand. So, we have this one. Remember, 0 is always at the pinky. But since we're looking for cosine, we're going to what? Count 0 here from the thumb going to the pinky. So 0, 1, 2, 3, 4. We're going to stop right at the pinky because the pinky is your 0 degrees. So now you got 4. Now square root it, you will have 2. Now divided by 2, you have 1. Therefore, the answer in this problem for the cosine of 360 degrees is 1. And now we simplify. 1 divided by 1 is just 1. Therefore, the answer here is 1. There we go. All right. So now we're good with second of 360 degrees. Now we're going to proceed to cotangent. So cotangent we have 390 degrees. Okay, so how about this one? 390 degrees. You see, in this graph that I draw, I only draw until 360 degrees, right? So we have a given of trigonometric function where the special angle is more than 360. It's basically 390 degrees, 390. So yeah, we could say that I think we're going to draw another graph, you know, a graph where what if it reaches more than 360 degrees? Well, yeah, you can do that. Then it's up to you on how would you find the exact value by drawing. However, if I'm going to do it, I'm not going to do that. It would be a waste of time. Rather, what I'm going to do is I'm going to get its coterminal angle. Basically, coterminal angle, if you recall in one of the previous videos that I discussed, coterminal angles are basically angles that are in the same side. Okay? The same side. So, my point is that we can get the coterminal angle of 390 degrees within the interval of 0 degrees to 360 degrees. Okay? So first, let's find the coterminal angle for 390 degrees between 0 degrees up to 360 degrees. In other words, is there an angle that is equivalent to 390 degrees within this range? So let's take a look. So the best way to do that, since this one is greater than 360 degrees, all we need to do is we will subtract 390 degrees by 360 degrees because it's greater than 360 degrees. So 390 minus 360, so this would be 30 degrees. Okay. Now, as you can see, 30 degrees is within the range of what? 0 degrees to 360 degrees. Therefore, we can say that cotangent of 390 degrees is just the same as cotangent of 30 degrees. Okay, there we go. Now let me erase this one. Now that we found its coterminal angle, now how can we get the value? So again, guys, uh, again, this is cotangent. So you do not know its identity. How would you convert it into cosine or sine or something? So here you have to think what identity that if we're going to convert it into different form, it has cosine, sine, or both of them. So we're going to apply the reciprocal identity for cotangent. Okay? Cotangent theta is equal to the reciprocal of tangent theta or 1 all over tangent theta. And we can just simply what do you call this one? We can just simply what do you call this one? we can simply have cosine theta all over sine theta instead. Okay? Because remember that tangent theta is what? Is sine theta all over cosine theta, right? If you remember. And remember that if you're going to simplify a fraction where at least one of the sides of the fraction has another fraction, so what happened is that you will copy the numerator 1 times you're going to exchange the position of the fraction on the denominator. So you will have cosine theta all over sine theta. And this is the result. Okay? So point being, cotangent theta is just the same as cosine theta all over sine theta. And because of that, okay, we can simply rewrite cotangent of 30 degrees as as cosine of 30 degrees all over sine of 30 degrees. Okay, so what are we going to do now? So now we can now get the value of each of the trigonometric functions. Or again, so we will use a technique here, okay? The technique, the hand technique here. Okay? So all you need to do is use your hand. Okay, use your hand, this one, all right? This one. So here's the thing. Cosine 30 degrees. So if it's cosine, you will start counting 0 to 4 from your thumb until you reach the angle. All right? So let's start counting from 0 to 4. 0 to, 0 to, until it reaches 30 degrees. So here, 0, 1, 2, 3. We're going to stop right here in this ring finger of mine. Here. Because in the ring finger, we have 30 degrees. Okay? 30 degrees. And since we are looking for cosine, so that means we count from 0 up to 4 at the pinky, right? We stop until here 30 degrees. So that means this is what? 3. This is 3. Okay, the pinky finger is 3. Now, what we're going to do is we're going to square root it. What's the square root of 3? So we will have square root of 3. Then after that, you're going to divide it by 2. So you will have square root of 3 all over 2 as a result. Okay? Now, how about for sine? So sine, remember, you're going to count 0 to 4 from your pinky, okay? From the pinky. All right? Then you will reach until the given angle that is what you're looking for. So let's start. 0, 1. So you stop until the ring finger here because again, in the ring finger, this is where 30 degrees is located. Now here on the ring finger, okay, so 0, 1. So you will have a value of 1. Now square root it, you will have 1. Divided by 2, you will have 1 half. So as a result, you will have 1 half here. Okay, there we go. All right, so now what we're going to do is we're going to simplify this fraction. So copy the numerator, square root of 3 all over 2 times the denominator, but the positions were exchanged. So you will have 2 all over 1. So cancel the 2's, you will have square root of 3 all over 1. So the answer here is square root of 3. So therefore, cotangent of 390 degrees is square root of 3. By square root of 3. Right? There we go. Wait. Let me just write it here. Square root of 3. Okay? There we go. Now, how about cosine of 660 degrees? Okay, so this is actually a lot. It's actually big number because if you're going to take a look at this one, it's actually more than 360 degrees. Okay, and it could be on it's either on third revolution or second revolution or whatsoever. But point being, it's greater than 360 degrees. So again, it's up to you if you're going to just simply graph a revolution where it is more than 360 degrees. It's clearly up to you. Okay, but again, in my case, if I'm going to solve it, I would rather find its coterminal angle. Okay, the coterminal angle of 360 degrees. Okay? Coterminal angle of 360 degrees between 0 degrees and 360 degrees. Let's find a coterminal angle of 660 degrees between in this interval. Okay, let's find it. Now, how? How are we going to do that? So, since it's more than 360 degrees, what we're going to do is we will subtract 660 degrees by 360 degrees. We're going to subtract them. So if you're going to subtract them, so 60, 60, you will have 300 degrees. Okay? Now that 300 degrees is located in this interval, so we can say that cosine of 660 degrees is just equivalent to cosine of 300 degrees. Alright? So now, uh, what is 300 degrees? Cosine of 300 degrees. So now that we find its coterminal angle, let's try to draw a graph. Alright? So let me just, I think erase this one. Erase. Let me just, never mind. Let me just, uh, the camera size should be like that so that you can guys see me, especially if I'm going to show my hands. Alright? Anyway, so, okay, let's start from 0 degrees, then 300 degrees. So, I assume that 300 degrees is here because overall, um, 300 degrees is located between 270 and 360. So, we can draw a angle starting from there going here. So, it's 300 degrees. All right? Then, we're going to find its reference angle so that we can use 0 degree, 30 degrees, 45, or 90 instead, right? Just like what we did earlier. So we're going to find the reference angle, okay, for this one. Now, if you are in, what do you call this one? If you are in, wait, oh, that sounds wrong. If the angle, much better, is in the third quadrant, oh no, no, fourth quadrant, okay, if it's in the fourth quadrant and you're going to find its reference angle, all you need to do is subtract 360 degrees by its given angle. So you will subtract 360 degrees by 300. So 360 minus 300 is 60 degrees. So your reference angle is 60 degrees. Now, here's the question. Is it positive cosine or negative cosine? So again, remember that cosine is your x and your sine is your y. So according here, your x is positive. Therefore, you will have positive cosine. So that means we can rewrite this as cosine of 60 degrees. Positive cosine of 60 degrees. Okay, that's it. So in other words, cosine of 660 degrees is just equivalent to cosine of 60 degrees. Now let's find cosine of 60 degrees. Okay, again, so you will use your hand, all right? So where is 60 degrees? It's here on your forefinger. And now you will count 0 from the thumb until 60 degrees. So 0, 1. So this is 60 degrees, right? So you stop right here. So the value you get here is 1. Now square root it. 1. Now divided by 2. 1 half. So the answer here is 1 half. There you go. 1 half. All right? So cosine of 660 degrees is 1 half. Positive 1 half. There you go. Now next, we have cosecant of 110 degrees. So in this case, it's actually a big number and yet it's negative. So this is less than 0 degrees, right? Less than 0 degrees. So in my case, again, I'm going to find its coterminal angle of 810 degrees between 0 degrees and 360 degrees. By the way how I write the range of the interval like this is just the same as x is less than or equal, less than, greater than or equal to 0 degrees but less than or equal to 360 degrees. All right? So here, now that we have this one, so let's find the coterminal angle of this one within this interval. The question is how though? So since it's less than 0 degrees, what we're going to do is we're going to add 360 degrees. Okay? Until we reach an angle that is within this interval. So we have negative 810 plus 360. We will have negative 40, 450 degrees. Okay? But still, this is still what? Less than 0 degrees, right? It's not even in this interval. Then we will, what? Add it by 360 degrees. Okay? So, okay, we have negative 450. Now, added with 360 again. So, you will have negative 90 degrees. But still, again, you know, it's still negative. It's still less than 0. Then we will do it again. Negative 90 degrees plus 360 degrees. I think that's 270. Let's take a look. Yes, it is 270 degrees. So 270 degrees is within in this interval. So we will stop right there. So we can simply rewrite cosecant of 810 degrees as cosecant of 270 degrees. Okay, there we go. So let me just erase this one. Now, again, it's cosecant, so it's not sine or cosine. So still, you can convert it into its sine form. Remember that the reciprocal identity of cosecant theta, like cosecant theta, is just the same as the reciprocal of sine theta, or 1 all over sine. So that means we can simply rewrite cosecant of 270 degrees as sine of 270 degrees. Now here's the problem. What is the value of 270 degrees? If you're going to take a look at the graph, 270 is here. Right? This is 270. Now you want to know the value, okay? So the thing is, for you guys not to be confused, all right, let me just erase the writing here. All right. In this graph, if it's in a quadrantal angle, it's easy for you to get the values here because the values involved here in the quadrantal angles, it's either 1 or 0. And remember that quadrantal angles, these are the angles at the what? At the axis, just like here. 0 degrees, 90 degrees, 180. These are your quadrantal angles. So if it's on here, like 0 degrees at that angle, so you will have 1, 0. If it's on 90 degrees, you will have 0, 1. If it's 180, you will have negative 1, 0. If it's 270, you will have 0, negative 1. And for 360, it's just the same as for 0, you will have 1, 0. So point being, at the right side of the x-axis, 1, 0. Left side on the x-axis, negative 1, 0. On the top, 0, 1. And on the bottom, 0, negative 1. Okay? So now that we have 270 degrees, let's find sine of 270 degrees. Remember that sine is what? It's the y value. All right? The y value here is negative 1. Therefore, this is what? 1 all over negative 1. And to simplify the answer, this is negative 1. Therefore, cosine of negative 180 degrees is negative 1. That's the answer. All right? I hope we could continue the other questions now, but due to the time that or the time limit that I must record or present, I must stop right now. All right? We will continue the other problems here in the next video. All right? But I do hope that you understand the techniques or the method in a way how I solve the problem. So see you guys soon on the part 4. All right? See you.